Okay, now we'll work on task 3, and the task 3 is having a function given to us, and we have to work on this function using the Newton-Raphson's method and also the bisection method, and we'll perform 3 iterations for each of them and see like how fast we come to the zero of this function using each of the methods. So let's start working on this. I've written the function for you already, and our first task is to use the Newton-Raphson's method and perform for, I guess 3 iterations and keep 3 digits after the decimal point and give a conclusion on this. So our x0 is given to us as 5 and we have the function given to us. Now let's find out the derivative of the function. So let me write it here. So the derivative of this function is equal to 3x squared minus 14x plus 8. And as you know the Newton-Raphson's formula already, I will just insert our values into the formula. Let me erase this here. So let's write it again. So xk plus 1 is equal to xk minus the function, which is x cubed minus 7x squared plus 8x minus 3 divided by 3x squared minus 14x plus 8. So we can write here for all the xk. So now if we have, first of all we have the x0 is equal to 5. Now we want to find out the x1. So here we'll have x1, so 0, the k will be the value of 0 here, so 0 plus 1 is x1 and k is 0, so it's x0 minus x0 cubed minus 7x0 squared plus 8x0 minus 3 divided by 3 times x0 squared minus 14 x0 plus 8. So now replacing x0 by 5 here, or you can already save this number 5 into your calculator as answer. So just press in your calculator the number 5 and then press equal to, and then 5 will be saved into the answer key. So then you can just replace, instead of 5 here, you can just write here answer minus answer cube minus 7 times answer squared plus 8 times answer minus 3 divided by 3 times answer squared minus 14 times answer plus 8. So when you press equal to sign now, this will give you the value of x1, which is 6. Now again, if you press equal to sign, you will get the value for x2, which is, I'll write it here, maybe not there. So x1 is 6, x2 is 5.7188 and x3 is 5.6862. So we are supposed to do 3 iterations according to the question. Therefore now we'll say the 0 of the function f given to us is approximately 5.6862. Okay, I think we were supposed to do it to 3 decimal places, right? Yes. So in that case we will have here 3 decimal places would be 719, and here 3 decimal places will be okay, so that's correct. So here will be 719. Okay, now for the task 3 part 2, we have to use the bisection method and do the same work as we have done in task 1 here. So let's work on this now. So we have task 3 part 2 now we're working on, and we have to first find out the interval. So let's take for the xu, that's the upper value, we could take like, let's say 6. So you have f of 6, that means in the function you'll put the value 6. Let's rewrite the function here again. So fx is equal to x cubed minus 7x squared minus 8x minus 3. So if I put 6 there, it will be 6 cubed minus 7 times 6 squared minus 8 times 6 minus 3. Okay, this is plus here, and this will give you the value for 6 as 9. Now let's put a value, maybe let's say 4 for x lower. We have the value 4 here, and that will give us 4 cubed minus 7 times 4 squared plus 8 times 4 minus 3, which is minus 19. So we have one value here which is greater than 0 and the other less than 0. So if we multiply f of xu times f of xl, which is 9, times xu, 9 times minus 19, this is equal to minus 171, which is less than 0, which means there is a 0 between this interval. So our first interval in this case then we can say is interval 1 will be 4, 6. So between 4 and 6 there is a 0 about this function. It could be very different from all of you. You could have different intervals, and you will work out differently according to whatever you take your first numbers as, and try to find out one positive and one negative number. So you will have to do quite some calculations and then find out which interval is suiting, or you're getting an interval, you're getting one positive and one negative, and then as soon as you get, choose that as your interval and work ahead. So here my first interval is 4 to 6, and if I start working on this now, so okay, here now we don't have to write the a, b and x value, I guess. So here no, the question doesn't ask that, so we can just say in that case the x1 is 4 plus 6 divided by 2, which is 10 divided by 2, which is 5. And we can also calculate the error one, which is b1 minus a1 divided by 2. So we have 6 minus 4 divided by 2, which is equal to 1. And x1 we have got. So now we'll put these values in the function. So we have function f of 4, f of 5, and f of 6. So they should be organized in consecutive numbers, so 4, 5, 6. And now for f of 4, as you have already seen, we get minus 19. For f of 5, we'll get here minus 13. And for f of 6, we'll get here 9. So this is less than 0, and greater than 0. So the interval is where the sign changes. So here there's a sign change from minus 13 to plus 9. So in that case, this will be our second interval. So let's write our second interval down now. So interval 2 is So interval 2 is 5, 6, and if we work it out now, we'll have here x2 will be 5 plus 6 divided by 2, which is equal to 5.5. And also for error 2, either you can do b2 minus a2 divided by 2, or you can just take e1 and divide it by 2. So your e1 is 1 divided by 2, so the error will be 0.5 here. And then again we'll arrange all of them here. I don't have enough space here, so I'll go to the next page. So I have to now write about f of 5 and f of 5.5 and f of 6. So f of 5 is minus 13, which is less than 0. Then f of 5.5 will be minus 4.375, which is again less than 0, and f of 6 is 9, which is greater than 0. So we can already see where the sign change is there. So our sign change is here from negative to positive, so this will be our third interval. So for the third interval now, we'll have here 5.5 to 6. And calculating the x3 now, we have 5.5 plus 6 divided by 2, which will be equal to 5.75. And we have to calculate the error 3, which is e2 divided by 2, which is 0.5 divided by 2, that will be equal to 0.25 here. And then we can do again all of those above, f of 5.5, f of 5.75 and f of 6, but then the question says us to only work until 3 iterations. So at the third iteration, the value of the x is our answer, so which we already got at the third iteration, the value of the x here. So we have here the 0 of the function is, or approximately, is equal to 5.75 here. Okay, and so here we have to do the 3 digits of the decimal point, so we can just put a 0 here. Now if you look previously to the Newton-Raphson's method, here we get at the third iteration the value as 5.6862, and for the bisection method we get at the third iteration 5.750. Now let's see where the actual 0 lies. So if you go to the graph here of the function, we'll have here the actual 0. So drawing the tangents, the actual 0 is at 5.686. So that's the actual 0 for this function here. So So if we go to the tab, you see like the actual zero is at 5.686. am I right? So according to the graph it's 5.686, but then for our value here we got it as 5.750 for the bisection method, and for the Newton-Raphson's method, again if I write here, the actual zero is actually 5.686. so you can see the Newton-Raphson's method converges to the actual zero faster than the bisection method if we are just considering 3 steps. Thank you.